Hi, hello, and what's up, amazing people, students, and lovers of chemistry out there. I'm super excited today to be with you on today's episode of Question for the Day. And on today's episode, we have a redox reaction, and they've asked us to balance it in an acidic medium. Alright, so right before we get into balancing this reaction in the acidic medium, let's check out the steps to be taken to balance this reaction appropriately. So first things first, we need to split this reaction into the half reactions. We'll have the oxidation half and we'll also have the reduction half. Next is we have to balance all the atoms except hydrogen and oxygen. And then we need to balance oxygen by adding H2O, which is water molecules. And then we need to balance hydrogen by adding hydrogen ions, H plus ions. And then next, we need to balance charges by adding electrons. And then we need to cancel out the electrons and add both half reactions. We're going to be doing this step by step. So I don't want you to freak out. I don't want you to be scared. I'll be with you every step of the way as we deal with this redox reaction. So let's get back to the question and apply the step one step at a time. So we have this question on the screen right now. Let's split this into the two half reactions. Alright, to split this, we have the first half, which is represented like this. We have Cr₂O₇², 2 minus, giving us Cr3+. And then we have the second half, which is Fe2+, giving us Fe3+. So now that we have the first step taken care of, the next step says balance all atoms except hydrogen and oxygen. But before we do that, we need to do something very important. We need to identify which part is the oxidation half, and we also need to identify which part is the reduction half. Now take for instance the second equation. Over here you can see the oxidation number of ion to be +2, and over here you can see the oxidation number of ion to be +3. In other words, the oxidation number went all the way from +2 to +3. Now I have a question for you. When the oxidation number of an atom migrates from +2 to +3, does it increase or does it decrease? Of course it increases. And we all know that when the oxidation number of an element increases, it means that oxidation has taken place. So automatically this becomes our oxidation half. And if this is our oxidation half, it therefore means that this one over here automatically becomes our reduction half. So now that we have identified our oxidation half and our reduction half, let's solve this question further. The next step says balance all the atoms except hydrogen and oxygen. Let's do that. So to balance all atoms except hydrogen and oxygen, for the first equation, we have Cr2O7 2 minus, giving us Cr3+. Now apart from hydrogen and oxygen, is there any other atom in this chemical equation? Of course there is. That is chromium. And over here you can see chromium has a subscript of 2, which tells us that we have 2 atoms of chromium on the left side. And over here we have just 1 atom of chromium. So that necessitates the addition of a coefficient of 2 to make chromium to be balanced on both sides of the equation. So we've done that for the first equation. We have 2 over here balancing chromium. For the second equation, however, there are no other atoms apart from hydrogen and oxygen to be balanced, because ion over here is just 1 atom and ion over here is just 1 atom. So that rule has been followed adequately. So the third rule says balance oxygen by adding H2O or water molecules. So let's do that very quickly. To balance oxygen, the first equation has this Cr2O7 2 minus, yielding 2Cr3+. Now we are balancing oxygen. Okay, so how many atoms of oxygen do we have? We have on the left side 7 atoms of oxygen, and on the right side we have 0 atoms of oxygen, which tells us that we need to add 7 molecules of water to the right hand side to make oxygen balanced. So we've done that for the first equation now. The second equation, there are no oxygen atoms, so we do not need to add any water molecules. So the next rule says balance hydrogen by adding H plus ions. So for the first equation, before we even talk about that, let me write the second equation, which is Fe2 plus, giving us Fe3 plus. So for the first equation now, we want to balance hydrogen by adding H plus ions. On the right hand side, we have hydrogen atoms, which has a subscript of 2 and a coefficient of 7. So 7 multiplied by 2 tells us that we have 14 hydrogen atoms. On the left hand side, there are no hydrogen atoms, 0. So that tells us that we need to add 14 hydrogen ions to balance hydrogen both on the left and on the right side. I'm sure you're seeing how this is playing out. So altogether, we now have the two equations. The first one is Cr₂O₇, 2 minus, plus 14 hydrogen ions or 14H plus, giving us 2Cr3 plus 7H2O. And the second equation is Fe2 plus yielding Fe3 plus. So now that we have that out of the way, the next rule says balance charges by adding electrons. Let's do that very quickly. To balance charges by adding electrons means that for every place where there is a higher positive charge, you need to add a sufficient number of electrons to balance the charges. Now, here is what I mean. For the first equation, we have Cr₂O₇, 2 minus, plus 14 hydrogen ions yielding 2Cr3 plus 7 molecules of water. So to balance charges using electrons means we'll find out the total charge on the left hand side, find out the total charge on the right hand side, and the part that is more positive will add a sufficient number of electrons to it. So let's do that very quickly. On the left hand side, we have a charge of -2 over here. Let's put it down, -2. Next, we have a charge of +1 over here by this plus sign. So let's put it down, +1. However, it has a coefficient of 14, which tells us that it becomes +1 multiplied by 14. So altogether, the charge becomes -2 plus 14. That tells us that the total charge is +12. On the right hand side, we have a charge of +3 over here. Let's indicate it. And it has a coefficient of 2. So that becomes +3 times 2, which is +6. And then there are no charges attached to this water molecule. So the total charge on the right hand side is +6. So we have +12 on the left and +6 on the right. Now the question becomes, where do we need to add more electrons? Of course on the left hand side, because this side is more positive. And we need to add 6 electrons in order to make the charges to be balanced. So now denoting that in the equation, it now becomes Cr₂O₇, 2 minus, plus 14H plus the 6 electrons we are adding, giving us 2Cr3 plus 7 molecules of water. And then the second equation becomes Fe2 plus yielding Fe3 plus. So now that we have that out of the way, the next rule, or before we even go to the next rule, remember we need to balance charges for the second equation. Now the second equation has a charge of +2 on the left hand side and +3 on the right hand side. So we need to add just 1 electron to the right hand side to make the charges balanced. So the second equation becomes Fe2 plus yielding Fe3 plus 1 electron. So now that we have that done, let's move on to the next step. Alright, so at this point, the next rule says cancel out the electrons and add both half reactions. What does it mean to cancel out the electrons? To cancel out the electrons, we need to make sure that the electrons are equal in both half reactions so we can cancel them out. Now, on the first equation, we have 6 electrons, and on the second one, we have just 1 electron. You can see them identified. So we want to make the electrons equal. How do we do that? We do that by simply multiplying adequately or appropriately. So we multiply the first equation by 1, since we have just one equation here, 1 electron, and then we multiply the second equation by 6, since we have 6 electrons here, so that the electrons can now be 6 on the first equation and 6 on the second equation. So doing that multiplication, the first equation stays basically the same. We have Cr₂O₇ 2 minus plus 14 hydrogen ions plus 6 electrons, yielding 2Cr3 plus 7 molecules of water. And then the second equation now becomes 6 Fe2 plus, yielding 6 Fe3 plus 6 electrons. So now we have the electrons equal in both half reactions. The final step says cancel out the electrons and then add everything together. To add everything together, everything on the left side goes with everything on the left side, and everything on the right side goes with everything on the right side. So adding everything together, let's see what we get. So we start with the left side. We have Cr₂O₇ 2 minus plus 14H plus 6 Fe2 plus. We have just taken care of everything on the left side, but for both half reactions. Now let's go to the right side. We have 2Cr3 plus 7H2O plus 6 Fe3 plus. This is our final balanced redox equation. Now we are done. But just to be sure, we need to find out if all the atoms are balanced on both sides and if charges are balanced as well. So let's check. For the first atom, we have chromium, Cr. On the left hand side, you can see over here we have chromium having a subscript of 2. So on the left side, it is 2. On the right side, you can see chromium having a coefficient of 2. It is also 2. So chromium is balanced. The next element we have is oxygen. On the left side, you can see oxygen has a subscript of 7 atoms of oxygen on the left side. And on the right side, you can see oxygen having a coefficient of 7, because this 7 affects everything in this chemical molecule. So oxygen is also balanced. Next, we have hydrogen. Hydrogen on the left side are 14 atoms of hydrogen. On the right side, you can see hydrogen has a subscript of 2 and a coefficient of 7. So that gives us 14 on both sides, because 7 multiplied by 2 is 14. So next element we have is ion. On the left side, we have 6 atoms of ion. On the right side, we also have 6 atoms of ion. So ion is balanced as well. All the atoms are balanced. Next question to ask is, are the charges balanced as well? Let's check it out. On the left side, you can see we have a charge of -2. Let's indicate it, -2 plus, we have a charge of +1 over here, +1 times 14, because of this coefficient of 14 in this atom. And then we have +2 over here. So let's indicate it, +2 in this bracket multiplied by 6 because of this coefficient of 6. So altogether we have -2 plus 14 plus 12. -2 plus 14 plus 12 gives us +24. That is the charge on the left hand side. On the right hand side, let's find out what the charge is. We have a charge of +3 here, +3, and then it has a coefficient of 2, so that gives us +3 times 2. And then we also have a charge of +3 over here, which is +3, and it has a coefficient of 6, so that is +3 times 6. Altogether we have 6 plus 18. 6 plus 18 gives us +24. So the charges are balanced and the atoms are also balanced. So let's write the equation one more time for clarity's sake. So this is the final equation right now. We have Cr₂O₇² minus plus 14H plus 6Fe2 plus yielding 2Cr3 plus 7H2O plus 6Fe3 plus. This is our final chemical equation. I'm sure you got value, massive value, from what we just did in this video where we saw how to balance a redox reaction in the acidic medium. If you enjoyed it, please like, share to as many people as you can so we can do as much good as we're able to. And please turn on the notification bell after you subscribe so you can get more videos as they come in on a consistent basis. Up until I come your way next time, my name is David, and all I do here is to take the mystery out of chemistry so chemi can make history. I will see you in the next video.